Three. All right, so for the first one, it says describe using a clear, complete sentence how the motion of two objects differ from the motion of object one. All right, so as you can see here, this is object one and this is object two. Object one is moving positively at a constant velocity, while object two is moving negatively at a constant velocity. And so, how you would interpret that for answer B is basically just doing this. You see, this is the positive horizontal line going at a constant speed horizontal, and this is the negative line going at a constant speed, but only in a negative. All right, so for the second problem, we have object one clearly going in a positive, continuous, constant line. And then for object two, it is at a constant line that is horizontal, completely horizontal. So how you would depict that here is basically the positive one is in the positive axis, and then it's going in a straight horizontal line. And for this one that's not positive or negative, it's actually on the zero line. So I kind of drew a squiggly here so it's more apparent, but basically it's just on the zero line, and it's just gonna go there continuously forever. Okay, so now we're on number 5, and number 5 says below is a qualitative motion map for Wandering Willie. On a coordinate axis below, sketch a graph that generally describes Willie's motion. So as you can see, it starts at 10. So what we're gonna do is we have our 10 right here, and it goes constant all the way down here, and then when it gets to 4 seconds, it remains at a constant speed until eventually rising up. So we have that depicted there, and then describe what is happening when Willie gets a position of meters. When Willie relocates a position of 4 meters, he passes for a second, then he proceeds to move with a positive constant velocity of 1 meter per second. Okay, so for number 6, we are considering the point versus time graph for flippers below. As you can see, the graph is depicted here. And for 6A, it says determines flipper's average speed, show your work. So for this one, we're going to use the equation of displacement, which is the symbol X and then the symbol T. And then basically we're just gonna fill that in. So 40 minus 10, 40 because it's the highest, 10 because it's the lowest. And then denominator 6. So 30, denominator 6. That just equals 5. So that's gonna give us 5 meters per second. As you can see, that lines up if you look at the data. And write the mathematical model for the line of reasoning. So for the equation, we'll use x t equals 5 t plus 10 meters. And then that's the equation that we'll use. And then what is flipper's motion at 18? So we can just fill this in by using 18 seconds. So we will have x in replace of 18 equals 5. Place that with 18 and then plus 10. And then that will give us 100 meters. All right. So for 7A, it says suppose you are driving along a steady 25 meters per second, nearly 55 meters. Draw the velocity versus time graph on the axis below. So how you would approach this is that it says that he's driving along a steady constant speed of 25 meters per second. So the way you would just write that is you would go here, and then you would draw between 20 and 30. 25, which is right here, 25 meters per second, and he's going at a constant speed the whole time, so that's all you need to do for that one. So for 7B, it reads, at time t equals 2 seconds, you reach down to tune in a different radio station without changing speed. At time t equals 5 seconds, you return your attention to the road. What is the displacement of the car traveled while you weren't really paying attention to driving? Okay, so how we do this is displacement. We use the displacement equation. Equals Greek symbol x, and then times Greek symbol t, and then we move down, so we just fill that in. So we have 25 meters per second times 5 minus 2 seconds, and then simplify that. That just gives us 25 miles per second times 3 seconds. And then this equates to 75 meters. So that is how we get that. And then finally, explain how you can use the velocity and time graph to calculate the displacement while you weren't paying attention. So basically, by looking at the graph, we can tell that we have a positive constant velocity of 25 meters per second. Then we can look at the 2's and 5's marker. So since we weren't paying attention, because these times we can count the number of seconds passed, which would be 3 seconds. Then we could use our average velocity of 25 meters per second and multiply for the time 25 meters times 3 seconds. Our end result would be 75 meters of displacement over the 3 seconds when you weren't paying attention. Yeah.